Hey everybody, I want to see if I can help you out with the hardest situation that comes up when you are factoring quadratic trinomials. And that's the case where you have some number in front of x squared. We call that the a value or the quadratic coefficient. And there's no greatest common factors that you can factor out. So before we go over how to do this kind of factoring, let's once again look at what it would be like to distribute. How do you get to a trinomial like this? So anyway, this is actually what the factored answer is going to be. We'll find out how to get there in a bit. But first off, let's look in reverse. If I'm distributing two binomials, I'll have a number in front of the x squared if one or both of the binomials have a number in front of their x. So let's once again just distribute out this expression and see what we get. I really like to multiply with my area model here. So now I'm going to just multiply this all together. 2x times 3x is 6x squared. 3x times negative 5, that's negative 15x. 2x times 2 is 4x. And 2 times negative 5 is negative 10. When I put this factored form into standard form, I have to multiply everything against everything. That's my distributive method. And then I have to take the four numbers inside of this box, and I got to add them all together. That means I'm going to combine any like terms, and I always have two like terms in the middle. And that is how I would distribute two binomials and end up with a standard form trinomial that has that quadratic coefficient. So now let's see if we can do this in reverse. And if I go up, the first step I have to do is start from this trinomial, and I need to determine what are the two numbers that I added together to get my middle term. I call it the linear term, but I need to figure out what were the two numbers that added together to get that linear term. So now let me start factoring this problem. I'll do this over here. Now, the typical way to do this, I use this big ol' X again, and this is just a way to help me kind of organize my guess and check, essentially, for figuring out what two numbers those are. And I gotta, in this case, I have to look at what is A, what is C. I'm gonna multiply those together. Negative 60. Then I gotta put my B value in the bottom, negative 11. So what I am doing with this x is I'm thinking about what are two numbers that would multiply to negative 60 and add to negative 11. The actual process, what I'm actually doing here is trying to figure out what are these two numbers. And again, there is literally an infinite number of pairs of numbers that add to negative 11. But there's only so many numbers that multiply to negative 60. So I always start with the top. So I don't always. Sometimes I just do this in my head. But if I struggle at all, I'll make a little T-chart here, and I'll try to think of pairs that multiply to negative 60. Well, let's see. I could divide 60 by 2. So maybe I've got 2 and negative 30. I'm making the bigger number negative because I see that it's going to add to a negative number. So the bigger number will have to always be negative here. Anyway, that doesn't work. What else could I divide 60 by? Let's see, I guess I could divide by 4. That would be 4 and negative 15. Oh, hold on. Yeah, oh, great. Hey, look at that. 4 plus negative 15 multiplies to negative 60, and it adds to negative 11. That's my answer. That's the first step. I had to figure out two numbers that fit the bill, multiplies to a times c, and adds to b. And again, the point of that was I needed to figure out what these two mysterious numbers were that added to my middle term. So now that I have that, for these more difficult factoring problems, I'm gonna have to basically rebuild this square over here, and that's gonna help me figure out what those two binomial factors are. So to do that, I'll make my square, I'll make an empty square here, divide it up. And I know that in every trinomial, I always have the first and last term inside the first and last box. The two numbers I just came up with, those are the linear terms of the trinomial. So I figured that out. And now the tricky part is, remember when I multiplied my box, I multiplied into each single box. But here I got to use greatest common factors to pull out every greatest common factor in every column and every row. So let's do that. Let's start at the top. 6x squared and negative 15x. Um, I think about I could divide both of those by 3 and an x. One's positive and one is negative. I'm noticing ahead of time actually I have two negative numbers here. So I'm thinking actually ahead that this greatest common factor will be negative. That should take care of all of my signs if I just have that one negative. Anyway, let me fill out this spot now. 4x and negative 10, those share a factor of 2. Okay. And then 6x squared and 4x, those both share a 2, a greatest common factor of 2 for the numbers, and they both share one factor of x. And then negative 15x and negative 10, like I said, they both have a negative. So I'm going to consider those as I'll make sure to take out one factor of negative 1. And then I can see that they both share a factor of 5. So that's a factor of negative 5. Now, once again, you have to look at, remember that my binomials, one binomial is written across the top, and one binomial is written across the side. And that's the process for factoring a more difficult quadratic trinomial.